This is your video to go along with Lab 2, the Graphing and Measurements and Data Analysis Lab. All right, this is one of your at-home activities, and I wanted to go over some basics of doing graphing, and that's about it. And then we'll go over the worksheet as well. So what I have here is a graph, obviously, and on the left-hand side, you'll see I have a few data points. I have some measurements of mass and some volumes. Now the mass is the thing that I actually measured, right? And that's the important, it's important that that's the part that I measured because the measured thing goes on the y-axis. Okay, we always put the measured thing on the y-axis. Okay, so in this particular activity, this person, took measurements of different volumes of a liquid. So at 1 milliliters, 2 milliliters, 3 milliliters, 4 milliliters, and they put it on the balance, and they determined the mass at each of those volumes. Okay, so we put the mass on the y-axis, the volume on the x-axis. Okay, and notice that each of my axes, the mass has units of grams written on the axis label, and on the x-axis, the volume has units of milliliters. All right, the other thing that's important to have on there are these tick marks, right? So each of my axes has tick marks at each of my points, and and I've spaced them out. That's the other sort of important thing. So I've got this whole screen to put a graph on. So I'm not going to put a graph that is like this big. All right, so I want something that is going to take up the space and use the entire graph surface. All right, so I put a title on here. So that's also an important aspect of every graph. And this goes for any class that you take where you have to make any kind of graph. Right? Every graph needs to have a title saying what is happening in the graph. Every graph needs to have axes labels with units. Right? Those are essential parts of every single type of graph that you ever make in any class. Right? Now I've plotted my data points on my graph, and I've included 0, 0 as a data point, because with this scenario, if I have 0 volume, I also have 0 mass. Okay, that's a real thing. And I've drawn a line through my data. Now notice that my line is not a connect the dots type of line. Okay. Also, the line does not necessarily connect 0 with my last data point. When you draw your line through your data, you want to make sure that it sort of goes right through the middle of all of your data. So notice that I have one dot that's a little bit above the line, and I have another dot that's a little bit below the line, right? So my line is actually an average of all of my data points, because the data points won't always fit perfectly on a straight line. Now when we go to calculate the slope, all right, and you'll have to do that once or twice in this activity, you use what's called the point slope formula, which you should have probably seen at some point in an algebra class. All right, so y2 minus y1 over x2 minus x1 is your slope. Now when you go to do this with your data, we are not, let me repeat, we are not going to use data points. Right? That is not going to be one of your choices. What we do want to do is along the line, we want to find places where the line itself actually crosses at a data point. So for example, right here, where we cross right on an XY point, and then I want to pick another spot where it's kind of far away. And in this case, one of my data points actually does fall right on the line. Right? So when I go to calculate this slope, I'm going to take data point 3.2 and 3 So my y value will be 3.2 up here, and then my y value down at the bottom is, looks like 246 minus 0.6. And then my x values are 3.0 and looks like 0.6. Right, so my slope will come from that calculation. So 3.2 minus 0.6 is what, 2.6? And then 3.0 minus that is what, 2.4? So my slope should come out to be pretty close to 1. So 2.6, let me get in the calculator, 2.6 divided by 2.4. So my slope should equal 1.1, right? And it'll have units, so these are grams and milliliters, so my slope will have grams per milliliter. All right, so these are, I'm doing this to try to avoid some of the common mistakes that we see a lot on this particular activity. Now let's take a look at the activity itself. Oops. All right, so the activity starts with the pre-lab questions, and you're given a data set here for question 1, and one of the first questions you deal with is which is the independent variable. Now the independent variable is the x-axis. Okay, because the independent variable it's independent, it doesn't depend on anything. The dependent variable is what is measured, and that's your y-axis. All right, so looking at the information that you're given, it says that the student measured the volume of a gas. That means that the volume is going to be your y-axis, right? And the mass of the gas will be your x-axis, okay? Now looking at what you're provided with here, so you're given a nice big piece of graph paper. So we want to make whatever your data happens to be, we want to make sure that it takes up most of this graph, right? So please don't try to put all of your data in a tiny little portion of the graph, right? Use the whole graph. So we've got your x-axis is your mass, so it goes from 1 to 7.7. So what I would do is maybe put like 1 down here and put like 8 way out here and sort of space things out in between. And then your volume goes from 0 to 0.56 to 4.3. So we'll have 0, and I would put probably like 5 up here and space everything out in between. Make sure you have a label with units, and a label with units for both axes. Okay. You also need to make sure that you have a title, and this goes for every single graph. All right, then you'll be asked to answer a bunch of questions about your graph. It says, what is the value of the slope? You'll use the point slope formula. Circle the points on the graphed line that you're using. And it also says, do not use the data table points. Okay, so when you make your graph, you're going to use the line, not the data points. All right, now let's moving along to our next section. So here our student measured the percentage of light transmitted. Right, so that's going to be the y-axis. Right, and we can see right away that the student made the wavelength the y-axis. Right, so you'll be asked to identify a number of mistakes that this student committed with this graph. Right, notice that there is no label here. That's not how you spell label, but you know what I mean. It needs units, title. All kinds of things are wrong with this graph. Okay, notice that the markings on the x-axis down there at the bottom are not consistent. So you go to 11 to 15, that's a span of 4, and then 15 to 20, that's a span of 5, and then 20 to 31, that's 11. Okay, you need to make sure that these things are even, right? So I'm trying to help point out some mistakes. Now, question A here for this graph and data, 0 should not be a data point. Explain why. So when I was showing the density, when we have 0 volume, we should have 0 mass, right? So with light and light transmittance, the amount transmitted does not correlate to a wavelength, right? I can have a wavelength of near infinity and still not have 100% transmittance. Or I can have a wavelength near 0 and have plenty of transmittance. So it's not necessarily, doesn't necessarily correlate to a 0 point. Also, if I have 0 wavelength, I have 0 light. So I can't measure anything at that point. All right, so again, we're going to take that data and correct the graph. All right, make sure yours has a title, axis labels with units, make sure it has tick marks, all that good stuff, okay? So continuing on, so here, so part B here, or whatever we want to call this, this normally would be done in the lab. All right, you would actually take measurements yourself and you would record this data. Since we're not doing that, what I've done is I've provided you with data that other students did collect. And I want you to actually write the data numbers into this table. So when you go to look at that, you'll see the final burette reading for sample 1 should read, and make sure you have units, 10.20 milliliters. And then the next one is 15.20 milliliters. I want you to actually put the numbers in this table, okay? Same thing here for the volume of water dispensed. You should have, you actually want to write these values into this table, right? Make sure you have units, make sure you actually record all of the data, the digits, and then here you will calculate, right? Density is mass divided by volume. Please be careful to have both the rounded and unrounded answers in that space. Right? Show your work. All right. Let's see. So, and then you're going to take that student data, make another graph, make sure it has title, labels with units, label with units, right? Make sure it takes up the entire graph, all that good stuff, right? Calculating a slope, make sure you use points that lie on the line, not necessarily your own data points, okay? This is always how this goes. Now, table D is using student data points from what would have been the groups in the class. And normally we would have had something like 12 groups, because there would normally be 24 people in the class. Right? So in the data that I send you, it will include a whole bunch of average densities. So you'll record these values for each of the groups. So group 1 would have a value of 0.9775. Group 2, 0.9704. And so on and so forth. So I think there's like 9 data points. So data for 9 groups. It's okay that there's not all 12. All right. And then here you'll construct a histogram. Okay, so histograms are basically bar graphs. So you're going to have along your x-axis, you'll have group 1, you'll have group 2, 3, 4, 5, and so forth. All right, so this will be group number. And along your y-axis, you'll have your density. Right, so let's say, and you want to make sure that it sort of takes up some space in the graph, so don't make densities down here, like way down at the bottom. Right, set your y-axis so that your densities will be around 1, and use that so you can show the differences between the various groups. Right, and you'll construct a histogram for all 9 of those groups. Okay. All right, now part E, table E here, you're going to be putting multiple data sets on the same graph. Right, and that's what you're going to do is you're going to use a different symbol for each of these things. So our measured thing is this solubility in grams per 100 grams. That's our measured. Right, so that means that is going to be our y-axis. Right, and then our temperature is going to be our x-axis. Right, so for nitrate and potassium, I'm going to use a different symbol for each one. So let's say, and then I need to also say what's what. So I'm going to say X is for the lead and Y is for the potassium. Okay, and actually I'll put that sort of key like here somewhere on the table, right? So I'll put an X for the lead, and let's say and let's not use a Y, let's use like a circle. All right, so I'm going to graph my various data points using X's and O's, right? And then I'll have a line for the O's and a line for the X's. Right? So this is how we can go about showing two different sets of data on the same graph. All right, now the question here, which is more soluble in water, lead or nitrate? And what you want to look for is which one of them has the line that is higher up on the graph. Right, and our last part, this is in your post-lab questions, and this is often a little bit like weird and confusing. So we have this data table and all of the students' densities, and these are totally made up. And then we're asked to determine the frequency of each bin and record it in table G. Now what that means is that for bin data, let's say bin data 0.80, I'm going to come up into this data table and I'm going to look for how many students got the value of 0.80. Okay, and in fact, there's only 1. Right, so I'm going to put a 1 here. Let's see how many students got 0.83. Let's see if we can find it. So we've got, looks like 1. Let's pick one with a few more. Let's try the 0.81. So we've got 1, let's see, 2, 3. Students got 0.81. Okay, so you're going to go through each of these numbers and determine how many students got that value. Okay, and then we're going to construct a histogram, right? So you'll have your various bin data. So on your x-axis, this is the independent data. And then on your y-axis, you should have your frequency. Right, so you're going to have a bunch of blocks for however many people, and those should be nice square blocks, for how many people got each of these various values. All right, and then you're going to answer some lovely questions. You're going to create some more graphs. Okay, remember to be careful about what is actually being measured. All right, so looking at this information too, reading this instructions, it says that the relationship by increasing the pressure of the gas and measuring the volume, right? If something's measured, it goes on the y-axis. All right, and then again, answering some questions about that. I believe that's all. It is. So, happy trails. Have fun with this activity. If you are someone that likes numbers and likes the sort of orderly usefulness of graphs, then this is going to be a really pleasuring exercise. Otherwise, just suck it up and get through it and try to have fun doing something else. And we'll see you in class.